Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leader series, Erosion and Scour Protection using in-situ concrete mattress. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past, present and emerging. Before we get started, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, HUSCA. HUSCA Australia provides the Australasian region direct access to 162 years of proven geosynthetics engineering, development, manufacturing, supply and installation experience. The highly dedicated local team refines 162 years of real-world universal geosynthetics experience and applies it to local conditions, with millions of square metres of high-quality materials applied across the Australasian region successfully. Today, we will hear from two speakers, followed by our live audience Q&A, and I encourage you all to please send your questions through to our speakers via the chat box. I would now like to welcome our first speaker, Dr. Charmaine Chia. Charmaine joined HUSCA Australia team as Solutions Engineer following a 5-year period at the Engineering Department at HUSCA's headquarters in Germany. This, together with her PhD obtained from the Queensland University of Technology, uniquely positioned Charmaine to provide the highest geosynthetic technical and engineering support to partners and clients across the Oceania region. Please join me in welcoming Dr. Charmaine Chia.
Good afternoon and good morning to everyone. First of all, thank you, Megan, for the introduction, and thank you all for joining HUSCA's first Thought Leader series, and I hope you enjoy. So my name is Charmaine, the Solution Engineer for HUSCA Australia, and I have the pleasure to give you the first section of today's webinar for erosion, scour, and mechanical protection with geosynthetic concrete mattress. And this is today's agenda. We will start with the basic information, explaining the different types of concrete mattresses, a brief introduction of the system, and then we focus on a presentation showing different applications with Incremat, with a different for erosion, lining, slope, mechanical, and uplift protection. And the presentation will then give some insights of Incremat projects executed around the world, followed by technical designs examples. And if you have any questions, please type into the YouTube chat box. So we do have a long-standing history with Incremat. Here you find an old book known as Plastics for Hydraulics, written by Zitcher in 1971. The book shares insights about the pioneering applications for plastics material, which now is commonly known as geosynthetics. What you see here is a concrete mattress that was produced by HUSCA in the early 1970s. So we do have a long-standing history of more than 60 years with Incremat. Here you can see some projects from the 1970s. One of the oldest projects is the Canal Imperial that was installed in 1973. It is an irrigation canal with Incremat standard, and you can see its condition in 2000 and also in 2011. Another old project that is currently in its service life is the Battersea in Wilhelmshaven. It was installed in 1977. As you all can see, the condition in 2008, both pictures at the bottom. So though geosynthetic concrete mattress has been installed over 60 years, they still present an unfamiliar construction element in the civil industry. So what is Incremat? As you can see, it's in-situ concrete mattress. It basically comprises two basic components, a geotextile formwork and highly fluid concrete. What I do mean by a highly fluid concrete, and here you can observe the flow cone test. Highly fluid concrete is poured into the cone with a certain diameter, in this case was 26 mils, and when it is released, the cone should be emptied within 5 to 6 seconds. There are different test methods to meet the criteria of highly fluid concrete. So alternatively, you can use actually an F6 consistency with a slump of 63 centimeters, or you can use a self-compacting concrete. Now, you may wonder if there's only one type of geosynthetic concrete mattress. No, in fact, there are more than that. So let's have a look. We have different mattresses types. So as you can see, we have Incremat Standard, Incremat Pipeline Cover, Incremat Flex, Incremat Filter Point, and Incremat Crib. Incomat standard is the state-of-the-art lining and erosion control because it's an impermeable slab and also can provide erosion protection. Then we have the IPC system, which is made of the Incomat standard. So we have the mechanical protection or buoyancy protection using Incomat standard that's wrapped around the pipeline. And then we have flex, filter point, and Incomat crib. So how do we actually differentiate between the different products? So let's take a look. There are two features mainly to differentiate the products, with or without vertical ties. Both Incomat Standard and Incomat Flex have vertical ties which provide dimensional stability, and this space would then be filled by concrete. Whereas Incomat Filter Point and Incomat Crib, they don't have the ties, but they have interwoven areas, which is known as filter points. Another feature that distinguishes the different mattresses is the permeability. Incomat Standard is the only one that can be used for sealing. Test results show that it has a permeability value of 3 times 10 to the power negative 11 meters per second, whereas Flex Crib have filter zones which provides permeability and allows hydrostatic pressure relief. So let's talk a little bit more about each product. Incomat Standard is available in a wide range of thickness, 8 to 56 centimeter. If a thinner concrete mattress is required, we are able to produce down to minimum thickness of 3 centimeters. Incomat Standard is the impermeable slab, as mentioned, so we usually use for channels, irrigation canals, and ponds, as both erosion protection and sealing element can be provided. Incomat Flex has a similarity with Incomat Standard, but with vertical ties. It's in a pillow shape, as you can see, with filter point areas. It is also available 8 to 56 centimeters, but we do recommend, if you have a steep slope, we only recommend a range between 8 to 30 centimeters. Because if we increase the thickness more than 30 centimeters, we notice the pillow would sag. So therefore, for steep slopes, we typically recommend 8 to 30. Then and it's typically used for wave and flow loads, high hydraulic loads, and also for canals, slopes, outlet structures, legs, and banks protection. Incomat Filter Point is a permeable mattress, and the thickness usually range between 5 to 40 centimeters, typically used for canal applications, also overflow sections. Also could be used as a membrane liner protection. The last product, which is a little bit more unique, which is Incomat Crib. The main difference is that it can be vegetated. The large interwoven areas will usually cut off, and soil is placed into these areas. It is typically installed above water levels, and the most common application for Incomat Crib is overflow sections. Now, let's take a look at some executed projects across the world, along with some technical design approaches. So first up, we have an erosion project in New Zealand. It is located in the central area of New Plymouth. The extent of the damage led the council towards removing and replacing the existing rock mattress with Incomat. The robust filter point mattress was selected as the best alternative due to its simplicity in installation. The Incomat filter point was manually laid on the subgrate, as you can see. And then we used an inline concrete pump that was pumped from a distance because there was actually no direct access for concrete trucks without actually significant disturbance to the surrounding vegetation. So the minimal machinery requirement for installation made with Incomat Filter Point made it a superior solution compared to others. Next, we have another project, erosion bank protection in the southern part of Taiwan in Kaohsiung. It is an area characterized by tropical climate, seasonal heavy rainfall, and the existing open rainwater channel was concrete lined, and over the years the channel was subjected to erosion attack on the slopes and the berms. Hence, urgent rehabilitation work were required. The regular concrete fronting was not really sought after by the local authorities, as they wanted something more ecologically friendly as well as aesthetically pleasing. So in cooperation with the local designer, the bottom slope compound was made of Incomat Filter Point, which enabled the relief of poor water pressure. For the upper slope compound, the crib mattress was selected because it could be vegetated. So during filling, what you notice is there will be some excess concrete melt that will seep through the fabric, but actually this increases the strength and durability of the concrete because there is less ratio of water to cement. So following the completion of the first phase of the project, what happened was there was a typhoon that hit Taiwan in August 2009, and the typhoon brought heavy rainfall, causing the drainage channel to rise to the maximum, as you can see on the picture. So even under these extreme climatic conditions, the Incomat erosion protection performed extremely well. Here we have another project that was done in Italy, the erosion protection system. The existing channel was subjected to weathering, and the erosion was affecting the stability of the surroundings. And more importantly, the channel was often subjected to flooding, which means it's prone to high flow rates. The project brief was to provide a constant thickness mattress that would prevent and resist high hydraulic flow. So as Incomat standard offers both sealing and erosion protection, and its simplicity to install, it was a better solution or a superior solution to other options. So we've talked about a couple of applications of Incomat. Let's look at a design examples for a canal lining. So what is the required thickness for this canal? So we have the flow as the input parameter, 2.5 meters per second, and we also have the dimensions of the canal. So which or what design method would be adopted? So here we have a flow load approach from Pelagic. So we need to take into account a number of different parameters. It includes the slope parameter, turbulence factor, depth, shield, and stability parameter. Once you selected the right factors, you put it into the formula, and the required thickness of Incomat can be then calculated. And in this case, the required thickness is 12 centimeters. The next example here is a scour protection system for bridge pier. The bridge you see here is actually a bridge that was completed in 1834. The suspended deck was replaced by a concrete girder in 1881, which was then replaced by a concrete deck in 1969. And note that the bridge are still in the original elements of the original bridge. Due to the high flow velocity, the river bed area of the piers is eroding, and it was endangering the foundation. Incomat standard with vertical ties provided a constant concrete cross-section under difficult installation conditions. This makes Incomat a superior system in comparison to other construction systems. So here you could see a bridge pier, which from the top, and also the underwater installation of Incomat 2120 with the two divers. So how do we actually design a scour protection around a bridge pier? So let's look at a design example. For instance, taking a flow at 1.15 meters per second with a pier width of 5.65. So this design is based from the Federal Highway Administration, so FHWA. The scour protection, how wide we need to protect the area, is actually 2 times the width of the pier. So this is given in the document at the bottom. You can see that. So we know how wide we need to protect. What thickness do we actually need to design with? So following this figure and knowing the design velocity and the stability coefficient, we would be able to determine the mattress thickness. So the flow velocity in this design was given at 1.15, and CL refers to the stability coefficient for turbulences at the bridge. So for example, CL 0.23 refers to wide bridge piers, or 0.12 refers to normal riverbeds. And as you can see, because our flow rate is relatively low at 1.15, the minimum thickness is actually 200 mils. So therefore, even though the value that we have doesn't give us the value at less than 100 mils, the minimum thickness for always bridge scour protection is actually 200 mils. So earlier I mentioned that Incomat filter point can be used as a membrane liner protection. So this is an overview of the Kasami Dam. In 2016, a lining system was required to protect the dam at Lebanon. There were 3 design phases with this project. So initially, the conventional approach was to construct a bituminous lining system, but such construction would actually require great effort as rollers would be needed to install the asphalt layer. In addition, given that the site is located in a cold region, the expected replacement period of the surface sealing would be lesser than the expected of 10 to 15 years. So hence an alternative approach was made to install a drainage geocomposite with a HDPE liner with granular fill. However, granular fill is not feasible, and it could be quite problematic for future maintenance and cleaning operations. So the alternative was to actually use Incomat filter point as a permanent protective layer. So you could see that is the overview of the dam, which has a 130,000 cubic meters of volume. And the other side, you could see the construction process, where you can see the setup of the installation, where you could see the drainage geocomposite, the HDPE liner, as well as the non-woven geotextile, as well as income filter point that is being installed on the slopes. So next, we have a slope erosion protection, or a intake structure that is done by Incremat standard. This is the largest man-made lake in Germany, 19 square kilometers, to be filled with 200 million cubic meters of water. This was created from a former pit open mine located at Cottbus in Germany. The flooding is carried out by the largest intake structure of Incremat standard with 200 meters stilling basin. So you could see this was a picture that we've taken during filling. As you can see, after it was installed in 2017, and you can see the first big picture right there is the filling in 2019. The upper right-hand corner is the initial phase of construction where Incremat was laid. And then the second picture is after the inauguration in 2018, where water was starting to flow in. The very last bottom picture is the top view of when the intake structure was completely built. So you could see this is a very large open pit that is going to be filled with water. So we talk about slope protection, and often we ask, so what is the slope stability with or without anchoring? So following the DIN 1054, the BAW derived minimum friction angles for subsoil for stable Incremat construction on slopes without anchoring. So the results are shown in this table. As you can see, with the slope inclination, whether it's above or underwater, and what's the factor of safety that's being adopted, and the minimum friction angles for stable Incremat constructions without anchoring. Also note that friction angle of Incremat is also equal to the subsoil if the subsoil consists of loose sand, gravel, or crushed stone. Sometimes we have a non-woven geotextile that's being placed under a Incremat, for instance, Incremat filter point or Incremat crib. Then the friction angle between the geotextile and Incremat would then be equal. Mechanical and buoyancy protection. So Incremat pipe cover, as mentioned earlier, we have a system in IPC Incremat pipe cover, which we actually use Incremat standard to wrap around to have mechanical protection or buoyancy protection. Although we have mentioned that Incremat's been used since the 1970s, but it's also quite an unfamiliar construction element in the pipeline industry. Traditional formwork such as wooden or steel shutters are generally time-consuming due to time required for the setup and removal. And the construction process gets a little bit more challenging when pipeline comprises non-linear shapes such as horizontal curve or shopkins. The use of rigid formwork would slow down the concrete coating process, and unlike the rigid formwork, the use of IPC, the use of Incremat with prefabricated zippers would then allow rapid case encasement. So what is really IPC? Let's have a look. So here you can see a project that was done in Germany, where you can see that IPC is being wrapped around and also filled with concrete. This is a 2DN 1400 pipes for potable water was installed across River Rue. For protection, Incremat pipeline of 20 centimeter thickness was chosen. And after the installation of IPC, the pipelines were floated into the river and sunk. So the total pipeline that was actually protected was 92 meters, with protected section of 54 meters. And for the sharp corners, as you can see on the other side of the picture, customized IPC systems was actually installed. So next we have another mechanical protection project in France that was installed in 2017. GRT Gas installed a new natural gas transmission pipeline between two cities in France in 2017. And the pipeline size diameter was TN 1200, and it was protected with IPC with a minimum thickness of 8 centimeters and average of 10 centimeters. So how do we actually design the required thickness for Incremat pipe cover? So we need to know what the input diameter is. So we need to know the external diameter, internal diameter, the density of the pipe, whether it's steel or whether it's HDPE, the coating, that's if there's any coating, whether that's non-woven geotextile, we need to know that, and then we calculate. So an average thickness of 10 centimeters was used for this project. the required concrete weight force of the pipeline is derived by solving the equilibrium forces. So it's quite straightforward. And then once you put in all the information, you know all your input values, then you can simply calculate the value, and the required thickness would then be derived. What we're going to show you next here is the preparation of how it's installed. How do you install an IPC? So what you see, the filling operations of the IPC here is relatively straightforward. Here is a 36-inch pipe encased with IPC system, and the pipeline is wrapped with the textile formwork, and then it's filled with highly fluid concrete with the inlets, which are sewn to the panel element. And here you see a 5-meter element, and which only took 7 minutes for the installation. Obviously, we won't see the whole thing. This is a bit fast forward. So let's watch the video. So the most important question, what are the IPC advantages in comparison to conventional formwork solution? So let's look at a project that was executed in France, a GN900 pipe with 3 IPC panels with no curves. We'll look into capital investment versus installation costs. With the use of Incremat, there is no lifting and no carrying. Concrete pump is required for both options, so that's the same thing. No additional machines are required with the use of IPC system. So, comparing the costs of the formwork, IPC has a higher cost than the wooden or steel formwork. It will be 90% cheaper if one uses the conventional method. IPC do require higher quality concrete than conventional system, so one would save 1/3 using conventional concrete, but nevertheless, one would need to compare it to the installation speed and the required labor. So how long does it take to install IPC? Approximately half a day with 3 workers, whereas with the conventional method, you would need 2 days and 4 workers and an excavator. And no removal is required for IPC. For the removal of the conventional formwork, it takes about half a day with 4 workers as well and 1 excavator. So conventional method is actually 5 times more labor intensive in comparison to an IPC system. So that's something to think about when you talk about capital investment versus installation. So how does IPC perform compared to conventional concrete cover? So what is the impact resistance when you compare both systems? So this is an impact resistance test that was done by GRT Gas in 2006. So what they did was they actually used a backhoe and tried to penetrate the concrete cover. And the results of this trial can be seen in the following pictures. So here you can see, in the first one, you can see the conventional concrete broke apart into pieces, whereas on the other side, the integrity of the IPC is still given. So that would answer your question, how does IPC perform? It performs well better than a conventional concrete cover. Another common question that we often get is, does the IPC affect the natural potential of the pipe? No, it doesn't. The natural potential of the pipe was actually measured on the built components 3 months post-installation, and as a result, the IPC does not affect the natural potential. So we have also the report if it's required. Another question, does IPC slide along the pipe? No, it doesn't. Cross-country infrastructure in Canada did some lifting trials. It was proven that the nicely fitted IPC system does not slide. And on the left-hand side, you see a 45-degree lift of the same pipe. And then on the right-hand side, you see a 90-degree lift vertically it was lifted for more than 10 minutes. And they also made markings to see any movements, and there was no movements made. For the same pipe, we also did some dragging tests. People do often ask, or client often asks, can we drag along the ground? Yes, we could. So the same pipe was dragged around the ground, frozen ground. This is in Canada. And on the right-hand side, you can see the braided section of the concrete encasement after the dragging operation. Please note that we didn't drag the IPC, we dragged the pipe itself. So this is the braided look after dragging. So in conclusion, we started with the geosynthetic history from the 1970s, followed by the different types of Incremat mattresses. So we had the Incremat Standard, Incremat Flex that we talked about, Incremat Filter Point, Incremat Crib that could be vegetated. We then took a look at the different applications where we talk about erosion and lining system with canals, we talk about scour protection with bridge piers, we talk about mechanical and uplift protection for IPCs. And we also look at the different approaches, for instance, the fluid approach from pelagic, FHWA, And lastly, we also talk about the IPC system itself and its advantages against conventional method. So thank you all for your time, and I hope you all enjoyed the session, and look forward to your questions, the Q&A session. Thank you.
Thank you, Charmaine, for your input today. I would now like to welcome our second speaker, George Hawkeswood. George has spent the last 15 years designing and implementing fabric-formed concrete solutions for marine construction and designing waterfront structures. George is a specialist in berth scour protection using in-situ concrete mattress and other underwater applications where reliability and control are essential, such as the Venice Barrage caisson foundations using fabric formwork. Please join me in welcoming George Hawkeswood.
Thank you, Megan, and thank you everyone for inviting me to speak today. So, yes, I'm going to talk about how we use how in-situ concrete mattress can be used for berth scour protection. So, contents today, I'm going to talk through what is in-situ concrete mattress and what are its main applications, how is it applied, how is it designed, and some previous project examples, and then how can we, as ProServe and Huska, support you to apply this rather unconventional tool, and when is it the best tool for the job to best help your projects. I'm going to start by just summarising what fabric-formed concrete is, starting at the very beginning. So I'm sure we all have a good understanding of traditional formwork and how it shapes and molds concrete, and that it's rigid, that it gives shape to the concrete, and that it doesn't have any function in terms of the permanent works. It's the concrete that does the job. It's very similar for fabric formwork. However, fabric's a purely tensile structure, so it can only give shape to the concrete when it's fully filled. But again, it's temporary in nature, and it's the concrete that does the work for the permanent one. Fabric formed concrete is best used whenever traditional formwork is impractical or slow or difficult. So generally we find ourselves working in any areas where you need to form a continuous thickness slab on slopes, or areas of difficult access, so underwater or down tunnels. As I've mentioned, it's all about the concrete, so might as well focus on the concrete for a moment at the beginning. So fabric formed concrete allows us to create very highly durable concrete. The concrete's pumped into an already positioned concrete mattress. The mattress fabric itself is permeable, and that allows excess air and water that might be in the formwork, especially underwater, to escape. And the pressurizing of the concrete being more dense means that this creates a very dense matrix inside the mattress, producing very high strength concrete with high surface abrasion resistant properties. So as you're mainly engineers in the audience, a bit of deep technical information. It's an excerpt from the British Standard for plain concrete, which isn't very commonly used these days. And this shows just how simple it is to have a plain concrete mix that's durable for over 100 years in the marine environment. The mixed properties aren't difficult to achieve. Using fabric formwork, I've talked about the water coming out of the mix, so it's just useful to point out that when we place the concrete, when we're pumping it, it's got a water cement ratio of about 0.55, which after curing in the concrete mattress drops to about 0.4 after that excess water bleeds out through the mix. So what is concrete mattress exactly? Well, it's two layers of fabric, so top fabric and a bottom fabric, separated by these what we call thickness ties, which are of a predetermined length at the weaving stage, and they limit how much the two fabrics can move apart, and that gives the mattress its thickness. Woven thicknesses are available up to about 600 millimeters, and where we're positioned in the market is, I think we're the only company in the world that doesn't weave or doesn't install concrete mattresses. So we're free to buy the fabric from whoever, and we buy the concrete mattress from Scour. It's the most reliable mattress out there on the market. So when we're going underwater in places difficult to access, we can really rely on its engineered properties. And then we engineer the mattress, cut it, shape it, add restraint, etc., so that it's suitable for the conditions that it's going into, and we train contractors how to use it. So we go to site to train them in that. So there's a few videos here just showing how concrete mattress works. On the right-hand side here, we have a filled piece of concrete mattress and an empty piece that's been zipped on. And I'll just play the video and we'll show it filling. You'll see that it's a very fluid concrete mix that fills it, tensions the fabric, gets those thickness ties tight. You know that the fabric's completely filled. I'll play the video one more time. This time I want us to focus on the joint between the two pieces of mattress. So you can see the first one filled has a convex shape, and the next one to fill around it will fill intimately around that shape, creating an interlock joint. So we call this a ball and socket joint. And in this next image, you can see that joint and how the two panels are interlocked and how the thickness of the mattress is maintained across joints. Okay, so how do we apply this to bird scour protection? First thing to take into account with bird scour protection is what is the source of scour. So generally, we're talking mostly these days about modern vessels becoming more powerful, deeper drafts, more maneuverable, so they can go into ports and harbours with ever lower resources, I guess. But primarily, it's coming from propeller scour. So this can be container ships with 10-meter diameter propellers, or it can be ferries, etc. Azipod propulsions really come up in the last few decades, primarily on cruise ships, being able to point in any direction, again having quite high power, create scour in different locations. Bow and stern thrusters, generally creating scour on slopes and hitting vertical walls. And it can also be wave and current actions, or fast ferries, the jets. The in-cap vessels fabricated in Australia, these jets can generally point along the surface with very high power, but when they're reversing, they point down towards the bed and can lead to some interesting scour patterns. So it's important to understand what the propulsion is and where the scour is going to occur. I'm going to focus on a scour at two different types of structures. The main kind of berthing structures that we have in ports and harbours. That's embedded retaining walls and pile jetties. So an embedded retaining wall, the name of the game is to protect the embedment of the wall and the passive wedge that supports the wall. So this is supported by the PN guidance that's used for design. There's some rough guidance there that says 5 meters past the propeller, but really that's analogous to protect the passive wedge of the wall. For pile jetties, again, we want to protect the geotechnical stability of the structure. So it's maybe not a perfectly drawn slip circle, but we're looking to protect the global slip failure by avoiding erosion at the toe and also local erosion at the piles. So I'll start by focusing on scour protection for quay walls. So there's a traditional method of scour protection, which is placing rock, and as vessels get ever more powerful and ever deeper in draft, the rock required becomes much larger, sometimes in excess of 2 layers of rock can be over 2 meters in thickness, plus the bedding layer beneath. So that adds up to quite a lot of dredging. But you can get the same performance from concrete mattress and for a much thinner protection, maybe just 300 millimeters instead of 2.5 times 2.5 meters for rock. The one advantage of this is that you can take advantage of this at the design stage and reduce the amount of dredging, reduce the amount of structure that you're having, because your span height's reduced greatly, so you can save cost on that initial construction. Or an existing berth, say maybe has rock protection at the moment, or has a lot of scour allowance with material that hasn't been dredged, and you've got medium-sized vessels visiting the port, then you could take out that rock or dredge deeper down to the comfortable limit of the wall, and you can install the mattress to protect the passive wedge that remains and ensure no scour occurs. So when we're talking about no scour occurring, we can be confident about that with concrete mattress because it's a completely sealed system. So we seal to the vertical wall. I've demonstrated how we create this interlock seal at the joints, and then we make sure that the edge detail is robust enough and located in the appropriate location where it won't get underscoured before maintenance can occur just locally where it's needed. So we will always design, fabricate and train the contractor to install concrete mattress in this sealed manner. So no erosion whatsoever through the plane of the mattress. We won't supply if there's a project where the design's for open protection. The difference between sealed and open, again, another look through the joints, continuous concrete slab, no erosion through the plane of the mattress is possible. At the edges, we're looking for no erosion to go under the mattress. So we'll have one of 2 or 3 methods to make sure that scour can occur near the edge without the edge being eroded. Open protection by contrast can be things like precast block mattresses or in-situ mattress that's installed with gaps. So this allows erosion through the plane of the mattress. It allows flow to get in between the edges or the joints. So the joints can be overlapping, but flow can act on those edges and create suction uplift, or it can get under the edge and cause failure. So in terms of comparing sealed and open mattresses, this chart's just designed to show that for very high bed velocities, when you're sealed, you need a relatively low thickness of concrete to resist, and that increases pretty rapidly if you then have open mattresses, say just laid onto the bed. You need a much greater thickness to be stable at relatively lower bed velocities. So how can you design concrete mattress? So we talked about the position and very, very light touch. So if you need more information, please contact us. In terms of the thickness of the mattress, there's 2 effects happening, which is the suction from the propeller. It's the rate of change of momentum across the propeller creates suction, and then also the suction generated from the flow touching down onto the bed. So you take the larger thickness required from both of those equations. Usually in this circumstance, it's dominated by the suction equation, and you design for it to be sealed protection. So these formulas are not valid for precast block mattresses or other non-sealed forms of protection. So just to talk about the rock edge and how important it is, it's really important that we can protect that edge from underscour. We've positioned it deeper so that the rock can be stable in the flow that it will experience, and it's away from the passive wedge, so it's in an area where we can now excavate. Now, scour can occur, and our maintenance regime of inspections every 6 or 12 months, as it may be, can then identify any areas where the rock apron is getting deployed and maintenance is required. A few years ago, 3 years ago now, we had an inquiry from Sydney where we couldn't get a rock edge to work. So we put our heads through what we could do to create an acceptable edge detail, and we came up with what we call the hinged edge block edge detail, which is very large concrete blocks tied back into the mattress. So these are 5 tons each, and the idea is that when the scour occurs, they can rotate and drop to a point when then you can then place rock that's of an appropriate or an available size, and it won't impinge on the draft of the vessel. So here's a quick video showing the hinged edge. So you see it's just fabric that's been rolled out, and this block, which probably started out as just 10 kilos of fabric, is now 5 tons worth of concrete, and all the diver has had to do is roll the fabric into position and connect a fairly lightweight hose and pump. So these blocks are extremely heavy, and they can't be flipped or rolled up by the propeller action. They're designed to be stable in that flow. There's different types of edge detail. I'll leave these here mainly for reference, but this shows how they can be constructed, what they look like when they're scoured, and how they can be maintained. Every edge detail of every mattress needs to be maintainable. That's a really key point, because we're never quite sure how the vessel is going to be used or where the scour is going to happen. We take our best guess, but we need to have that surety of being able to go in and maintain it so that it can't get underscoured. So how is concrete mattress installed? Well, you have a pump and a concrete wagon on the surface, the fluid mix. You dredge the bed nice and level with your toe trench, prepare the mattress on a roll, drop it down to the diver so that he can connect it to the wall. He rolls it out and he zips it to the previous mattress, which is a relative. We don't have good videos from underwater, unfortunately. It's usually a bit dark in ports. It's a relatively simple process for the diver to do as soon as you've got the 2 pieces of fabric next to each other. And then it's pump filled from the quayside, so just with the pump and the concrete truck. We always start at the lowest point and work in tremie fashion back towards the wall, and we have particular methods to make sure that the mattress is full everywhere as you progress, to make sure that there's no areas under thickness. So where have we done this before? Well, in terms of finished projects, we finished one, and I'm just finishing a second one in Ashdod in Israel. So this was quite a large new build container terminal. The one we're working on at the moment is an existing container terminal where they've really appreciated the solution and what it can do, and they're employing it more widely. It shows how flat the concrete mattress can be. That's 2 panels. That's about 10 meters wide. This was a trial that was used for training the divers and showing the client how it worked. Okay, so I'm going to, conscious of the time, so we're going to run on to the piled jetties, piled revetments. So here it's a very similar process. It's just a few more complicated elements, like the mattress is coming up through the intertidal zone now, and we've got piles puncturing the plane of the mattress. Often, traditionally, rock has been used on pile jetties, but depending on where you are in the world, you can't get rock of an appropriate quality at an effective price and practicality. And it can be difficult to place. So in terms of the construction sequence, you have to place the rock after piling before you start work on the deck superstructure. So it's on the critical path. With fabric, it's a bit simpler because you can place the fabric around the piles, clip it onto the piles with the decks in place. Before the deck's in place, you've got a lot more flexibility, so you can take it off the critical path. Again, here we're focusing on seal protection, so no erosion through the plane of the mattress. seal at the wall, the joints, the edge detail, and then now as well the piles to make sure there's no erosion. Because we're in the intertidal zone, there's a need for some porosity to be incorporated into the mattresses. So we place a filter layer beneath the mattress, size the thickness of the mattress to resist the wave uplift, and have a lot of porosity factored into the mattresses so that they can release that pressure. The mattress installed can be installed below the deck, so that it can allow a land infill method of construction, so the piling can take place from a land berm, and then that can be dredged out. So its mattress allows a lot more flexibility in construction than any other method. So precast mattresses are going to need cranes, same as rock, etc. Significant program advantages available to using concrete mattress. So mattress can be floated over and lowered much in the same way, just on a bit of a slope this time as before. It's rolled out and connected to the piles, zipped onto its neighbour, and then the diver fills from the surface just as before. So here's a video, some crystal clear waters. The diver's rolling the mattress down the slope, taking the bottom of the mattress and connecting it to the piles. They're going to come back in a moment and connect the top of the mattress to the piles before they fill. So now the mattress is empty, but it's completely connected to the piles. When it fills, it will push tightly onto those piles, creating sealed protection. And this is a video of what it looks like once it's filled. So on this project, we had a few increases in thickness as we went up the slopes. That's a change in thickness you can see there. You see the concrete pushing tight against the piles, porosity holes, and another change in thickness as you get right up into the wave zone. So this one was actually very thick, over 0.5 meter thick in that topside. The porosity holes incorporated in. So where have we done this before? Well, after the earthquake, we were involved in the rebuilding of the port in Port-au-Prince in Haiti. So this used the land infill method, so piling on a land berm and then dredging of the slope. It was simple to float out the fabric, pull it out of the bundle connected to the piles, achieve this profile with the seal protection. We've also undertaken a similar project in Puerto Quetzal in Guatemala. This one was concrete piles, not steel piles like Haiti. So you can install it with raker piles, etc. as well. Here you can see part of it was above the water line, so you can see the porosity holes incorporated there for the wave action. Here's a demonstration we undertook on the pile seal to show that it sealed tightly and maintained the stone and sand that's going to be on the slope underneath the mattress in location. So just to summarize the advantages of using concrete mattress and on these two applications, for a key wall or a level bed berth, then you're protecting the passive wedge. The concrete mattress can be approximately 7 times thinner than the equivalent rock armor. And if you wish, you can use your existing structure, deepen the draft, and install the concrete mattress, or for a new build, you can have the savings on span height. For a pile jetty, it's the only method that can be reliably installed under the deck, meaning it can be retrofitted to existing structures. We can bespoke position piles if they're a bit all over the place, older structures. With good survey information, we can cut the holes in the mattress in the right place, so you can use it on existing structures. Or you can use it new build, and the contractor can have their program savings and get their client into operation a little faster. So just to summarize, we've given you some new knowledge. So how can we help you to provide the best solutions for your projects? So first of all, you can follow us on LinkedIn to learn about other things that we do, just in bite-sized chunks. So we showcase our main applications, they're very brief posts and something that's easy for you to follow. For in-depth information, you can go to our website, to the resources tab. So we've got technical papers on the design of concrete mattress there, building on the information that you can get out of the current PN document. There's a lot more case histories and descriptions of different solutions. Once you've got a project in hand, we're more than happy, we'd be delighted for you to contact us. You can come for technical advice. So it could be interpretation of the PN guidance, asking us for approximate extents to get the edges in the right place. We can do example calculations for you, sketch up what particular solutions might look like. And that's all free of charge in the initial stages until someone's interested in supplying. And of course, we can do webinars more targeted to particular companies or projects if that's of interest. I imagine the questions and answers are coming up a bit later, but just like to thank everybody for their time and look forward to answering your questions later on. Thank you.
Thanks, George, for your input. And yes, it is time for our Q&A, and it's our audience's turn to get involved. So please ask our speakers your questions via the chat box, and I can see quite a few have come through already, so thank you. And also a big thank you for everyone who submitted questions while registering for tonight. We might kick off, George. Sorry, I'll throw one straight to you. And this question's come through from Stephen Paul from Victoria. And his question is this product useful in constructed waterways?
Yes, thanks for the question, Stephen. Well, yes is the quick answer. It depends a bit on the structure that you're protecting within that waterway. So we've worked in canals, protecting the walls of the canal, preventing erosion mounding. Did one a couple of years ago where there was a tunnel passing under the canal, so protecting the overburden on top of that tunnel. So yeah, it can be outfalls, spillways, just to protect some local areas. So yeah, it really depends what type of waterway it is, but certainly, yeah.
Excellent. Thanks, George. I do have another question, and this might be this one's come through from Lawrence Eckard from Queensland. So thank you, Lawrence, for your question. It's all about cost comparison versus the traditional rock. So maybe, George, did you want to kick off with this one?
Yeah, so in our experience, it varies depending on location. It varies all over the world. Some areas have good access to high quality rock, therefore rock's a bit cheaper. You're not transporting it as far. You can get the sizes required. And in other areas, that's really not possible. So we have contractors very keen to move away from rock solutions, maybe in their design and build project. We're doing one currently in Iraq that we know the contractor's been very keen to move away from rock. So they don't always tell us the numbers exactly, but in the UK we've supplied directly to a contractor that owns and operates quarries, rock quarries, and they also undertake some construction work. And they've bought concrete mattress off us when it's been more cost competitive than installing a rock solution. So I'm afraid I'm not able to give a perfect answer on that one, but it depends on location. It's probably the method.
Excellent. Charmaine, I do have a question for you, and this one's come from Jacob Bryant from Queensland. And the question is, well, there's actually two questions. Is there a scale restriction to the use of in-situ concrete mattresses? Is the first one. And then the next question is, would they be applicable to smaller size projects, or does the cost not justify the benefits when compared to other methods of ESC?
Thank you for the question. So, is there a scale restriction to the use of concrete mattresses? So there isn't much of there's not no scale restriction. These panels are assembled together to cover large and small areas. So it's project customized base. So there isn't a restriction in terms of how big or how large you need to be. So you can go as for pond lining, it's all customized, the panels all assembled together, or as for as big for canal protection or birth protection, as George presentation, we assemble them and then zip across. So it's just customizing the panel size according to project requirements. Cost comparison in comparison to erosion control methods and other erosion control methods, it all comes down to capital investments versus installation as well as maintenance. So if you look at the capital investments of maybe, for instance, the initial cost could be a little bit higher, but the installation time that you save using using concrete mattress would be much higher. Even logistics, for instance, if we're talking about one truckload could actually carry about 9,000 square meters of geotextile. In one truckload, how much volume of stones could you actually carry in comparison to covered area? So that's an overview of that, and also not about in addition to that, also about the maintenance. So for instance, you probably need to do an annual maintenance with ripraps and armor stones. So annual maintenance is required, and you need to replace the stones. You need operators on site, whereas for concrete mattresses, once it's installed, minimal inspection is required. So that would be the short answer. So the short answer will be you would have to look at the total overview of it. So what is it? It's project specific, but at the end, from the overall point of view, it is actually more cost effective to use geosynthetic concrete mattress in comparison to other erosion control methods.
Excellent. Thanks, Charmaine. George, a question came through with regards to what design standards and/or guidelines are recommended for the design of concrete mattresses.
So for bird scour protection, the principal guidance is the PANC protection. The PANC Working Group 180 design guidance, which is currently being updated. We understand only over a few months away from coming out, and I touched on some of that in the presentation. There's also technical papers that we've produced. Martin, my father, has led the charge on that over the last 15 years, producing a lot more design information and taking scale model testing that's then been peer reviewed. So those papers help with bird scour protection design and also design for bridge scour protection, which is quite common in the UK. We do a fair number of small bridges, and just building on the question Charmaine was answering before. I had one of those bridge protection projects come across my desk yesterday. It's only 25 square meters, so it's still an appropriate method to use. So the scale, in that sense, doesn't really get in the way.
Mm-hmm. I have a question, and it's come through from Sean Sanford, and I think this one could go to both of you. Undermining, how is this avoided? So who wants to kick off with that one?
Shall I start, Charmaine? Yeah, I'll start. So, plain concrete. It's rigid. It's not flexible. So we have to make sure it's supported. It's got relatively low strength in terms of spanning over scour holes or any areas of erosion. So we do that by, first of all, embedding the edge of the mattress to make sure that some scour has to occur before the edge can be exposed. And then in the presentation, I showed the rock falling edge apron, which can be very large rock if that's what needed to be stable, 1 to 3 tons on some berths. Otherwise, it can just be riprap, or in the case of rivers, just putting back the bed material to provide some resistance to the scour that occurs and get you through till you do your inspection to see if there's any scour that's occurred at that edge or near the edge or threatening to occur at the edge, so that you can go and replace it with more material.
Charmaine?
No, yeah, so it's exactly what George mentioned. So for a smaller scale where we look at for slope protection for rivers, we typically go have for embedded toe or Dutch toe where we, for instance, for the embedded toe, we would typically embed it to the expected scour depth. For Dutch toe, we would also use stones to actually to be filled in the trench as well. So there are different methods, but it's exactly what George mentioned as well. So we typically do recommend to use the embedment system, whether it's with stones or whether it's with the expected scour depth. So that would be the approach to prevent undermining.
I think that's general guidance as well for most mattress systems, including precast mattress. So we often see precast block mattresses installed flat on the bed, and people allow for the edge of the mattress to drop, where really it's quite vulnerable to getting picked up and lifted. So the guidance we've seen for precast block mattresses does say that you should embed that edge as well.
Well, George, one of the questions that came through live was from Mario, which was, how do you fix the mattresses to the ground to stop hydrostatic pressures and turbulence from lifting it?
Well, we don't. We don't. So we just we design the dead weight of the concrete mattress to be sufficient for the suction uplift, whether it be from the rate of change of momentum of the propeller in the water column creates a suction, and also you get the aeroplane wing effect of the fast flowing water over the top. We always make sure that the dead weight is sufficient to resist those forces. So there's no mechanical fixing through into the ground. It's just the dead weight.
Excellent, thanks. Charmaine, David Stefani is watching live today, and David has a question for you. How does Incomat mattresses perform under vehicular loading?
That's an interesting question. So Incomat concrete mattress, the main application is for erosion and scour protection and lining application. So it's not mainly used for vehicle loading. Despite saying that, we do have taken into account that before in the past. However, we noticed that with such application, typically a very thick concrete mattress is actually required. So it comes down to cost effectiveness, whether that thickness would be actually suitable for the project.
Thanks. George, you've got another live question. There are a lot of live questions coming through, so thank you to everyone. This one's from Pratash, and his question is, for the underwater installation, how do you monitor any issues in the future?
Yeah, it's a good question. So we rely primarily on bathymetric surveys. So now we get some very good multi-beam type information that we didn't used to get. It shows fairly well what's happening underwater. Diver surveys can also be used. That was what was done traditionally. But I think the multi-beam, you probably get much higher detailed information than sending the diver down. So once you've installed a project and you start operation, we'd want the first inspection to happen relatively quickly, maybe 3-6 months after first use, just to see if there's any particular behaviours or extra scour in certain locations that wasn't expected, to build up an understanding of how that area is going to react, so that you can then plan your maintenance with plenty of time. So it might be 3 months before you need to do the first bit of maintenance. It could be 100 years you never do any. It really depends on the specific location and how the vessels are causing scour.
Excellent, thank you. Joshua Brown has sent through a question tonight, and I might direct this one to you, Charmaine. There are areas around Australian beaches which have been washed away due to the erosion of sand. Can this product be applied to protecting these beaches?
Yes and no. Yes, so not directly. So typically for erosion control protection for around the beaches, we typically would recommend to use coastal protection tubes. When the tubes are being used, like for example, for breakwaters or for groins or even for dune reinforcement, we typically could cover them for UV protection with Incomat. So that is the way that we would do if you were to install them around the coastal area.
Excellent, thank you. George, I've got a question which has come through from Peter Thew. So thank you, Peter, for your question. Will an Incomat Flex mattress settle if when erosion occurs underneath it? For example, at the entry exit point of a culvert.
Okay, well, first of all, we would like to design it so that there's no erosion occurring underneath it. So we do design for settlement. So one project we're working on at the moment, the piled revetments plan to have somewhere between 200 and 300 millimeters of settlement during the design life. So in that case, we've adopted Incomat Flex and designed the dead weight so that it's stable. So we have some very thick portions, 35 centimeters thick in the main blocks, and then some very narrow edges to it, so that goes down to 50 millimeters, 75 in places. So that's designed to, when it's unsupported, those very thin pieces crack, and the mattress will drop to sit on the surface again. So in terms of an entry or exit point of a culvert, yeah, we look to design that for zero erosion through the plane of the mattress.
Excellent. Thanks, George. We've got a question which has come in, and I think this one would be for you, Charmaine. It's from Stephen Paul, and his question is, do you have any examples of using the crib product in constructed waterways or creeks? Is the product accepted by many councils and drainage authorities around Australia?
Thank you for the question. So we are working with local authorities like different councils in South Australia, for instance, where we're actually designing for using Incomat crib for the protection. So typically Incomat crib is used very commonly in overflow sections in Europe. For local ones, we are in the midst of, as I said, actively working with local councils into designing them, as it's relatively new in Australia, but it's been a long-standing product. So it's just a matter of getting the councils to work with us, how to design and how to actually install in different sites in Australia.
Excellent. There is another question, George, that came through from Peter Thew. He asked, can you go to a site in Indonesia to train the contractors?
Thanks, Peter. So yes, indeed we did. The last time being, I think it was the early 80s. We did a fair amount of river protection along the river in Balawan. So yeah, I guess it really depends on the scale of the project. If it's a small river structure, then it's probably going to be quite expensive to get us out there with the time to be on site. But if the project runs up to a certain scale, then yeah, it's cost effective to do so. Take our expertise and impart it to the local contractor and labourers doing the job. So we travel all around the world. I think we've got. Sorry, Megan, just to say that I think in the last month we've been to Iraq, Sweden, visiting the UK, Virginia in the US. So yeah, we get around the world.
I've got another question, which maybe you, George, maybe you, Charmaine, and it is from David Stefani. Can alternate shapes be manufactured? Sorry about that. Other than rectangular prisms?
I'll jump in first, Charmaine, if that works.
It's customizable. Sorry.
A bit of lag. Yeah, it's fabric. So same with clothing. You can make any shape you want. All we're really looking to do is make sure that the end result, the concrete, is the desired shape. It's protected right. But yeah, in theory, any shape is possible.
I'll jump to Charmaine. You didn't want to add anything to that? No, I think
so as what Josh mentioned, that it is a customizable shape. So whatever it's panels, so we can actually do it in any configuration that is required. So we have done prisms, pizza shapes for interesting corners as well. So that's just something that we have to account for when we have the layouts of the locations itself.
Excellent.
And one
Thank
further
you.
point, we have worked with Huska to weave bespoke thicknesses that vary along the mattress. So that's quite interesting, where we're dropping down from 35 centimeters thick down to 5 centimeters back to 35 in places. So the flexibility is quite remarkable.
Excellent. So let me have a look at. So we've had quite a lot of questions come through. I might just go to the next one. And this one, the questions come through from Trent Johnson. George, what is the slope limit for mattress installed under a piled wharf? Also, do you consider the mattress? Sorry, I'll say that again. Also, do you consider the piles as anchoring the mattress?
Yeah, this is a good question. Thanks, Trent. So, slope limit. Well, there's two criteria kind of working against each other here. So, in theory, you can lay concrete mattress on any slope, but then in terms of practicality, when you have piles, the steeper the slope that you have, the more variable when you've got your slope preparation tolerance in place, the more variable the distance between the piles is going to be, because you've got a greater vertical distance between. So we find a general comfortable slope is 2 to 1. That's quite simple to achieve. We've gone to 1 to 1.5 in the past, and it becomes much harder to manage in terms of slope preparation. Tolerances to go to 1 to 1. And then the second point is that when you're filling the mattress, you're limited by the vertical head pressure that you're putting into the mattress. You don't want to rupture anything. It is fabric. It does have a limit of how much height you can fill in one go. So the steeper it is, the more carefully you'd have to control the filling process. It essentially just means filling slower. So it's not hard, but the steeper it is, you get the installer has less leeway. And do we consider the piles as anchoring the mattress? Well, as we're tied to them, using webbing and carabiners, then it's very much anchored in terms of against slippage down the slope. But we don't take it as any formal restraint other than just in the temporary works.
Excellent. We've got a question, and I'll throw this open to the two of you. It's from Robert Bruce. Any comments on how the in-situ concrete mattresses may be used as an alternative to shotcrete, including serviceability? Oh my goodness, I can't get my words out. Including serviceability life. Who wants to start with
go ahead.
Yeah.
I guess we had a project that we also compare in terms of in-situ concrete mattress in versus shotcrete. So what we do when we shotcrete is when we do it for underwater application, for instance, you can't really control the amount and the thickness required. So in comparison to concrete mattress, which gives you the guaranteed thickness and a uniform thickness across the mattress, and so your volume of concrete is much more measured and controlled, and serviceability life between both, you're using concrete anyway. So it's at the end of the day, it's how you actually control the amount of concrete and how much wastage you would do if you just shotcrete the entire thing underwater, which is actually really difficult to control, and also to measure the required thickness underwater. So the use of concrete mattress, which guarantees the constant thickness mattress, would be much more efficient in comparison to shotcrete.
Excellent. George, did you add to that one?
Yeah, I'd only seen shotcrete getting used in tunnels, so sprayed onto walls, and I can't think of a method of using using concrete mattress over walls for the soffit of tunnels. So yeah, good answer, Charmaine.
Charmaine, I've got another question for you, and this one's come through from David Lee. For hydraulics, what is the roughness coefficient?
Yes, so for Increment standard, that is 0.0039. So that's the Increment standard Manning's roughness coefficient value.
Excellent.
And that's about as flat as it would get, isn't it?
Yep, indeed.
Now, this question you may have already answered, but it's come through from RIAG, and is this effective on rock slope? George, sorry, I'll throw that one to you.
So to put the mattress on top of a rock slope, we do it frequently. So when I showed the mattress going through the intertidal zone, and we need to allow those porosity holes to allow the water that's under the mattress to come out through the mattress to prevent that hydrostatic uplift. And then we're typically casting onto stones, maybe 250, 300 maximum diameter. So there's no issues with that. Putting it onto larger rock would potentially cause an issue, because you might have large areas of the bottom of the mattress unsupported. So with the concrete pressure going through, then it may lead to rupture of the mattress fabric. So we would look at the grading of the rock on the slope, and we would look at the porosity required to see whether it's appropriate, and then ultimately you carry out a small trial just to confirm. On one project where the gaps in the rock were too large, a small amount of rock pattern grouting was undertaken beforehand, before the mattress was then laid on top, just to fill in those holes. I think some stone was placed before as well onto the slope. So there's options depending on this project specifics.
I've got another question. It's come through from Randall. And he asked, do you have examples of your products used for boat ramps and high tidal range locations?
Yeah, that's certainly boat ramps. Sorry,
not that I came across any boat ramps before. Not.
Yeah. Fair enough. Do you want me to move on to the next one?
Well, we have done some small boat ramps in the past. So yeah, high tidal range. In the waters near where I am here in the English Channel, we can get up to 12-meter tidal range. So it's just about designing enough porosity either around the sides of the ramp or through the ramp if you really had to make sure that you can allow that water to dissipate. But yeah, I mean, the mattress is a reasonably smooth surface, so it's with the fabric on top, the friction might be an issue. And the last time we did a very large one, I think it was more than 20 years ago now, so it's not something we do a lot of, to be totally honest.
Thanks. Thank you both. I've got a question, Charmaine, and it's came through from Mayran, and there are two questions. And I know you did talk about this in your presentation, but just to recap, if this method can be used for sea erosions or for rivers or any other places, and can this method be used in vertical situations?
Yes, so definitely we can use, apart from the berth protection, we can use it for canal applications, lining, pond lining, breach scour protection, so that's not an issue. Generally not for vertical applications, but for other applications, for erosion, anything that comes into rivers, canals, pond lining, as mentioned, slurp protection, overflow sections, even as a membrane protection layer, these are all applications that could use Increment as a product. And their second question, yeah, vertical applications, unfortunately not. It's not been designed as this way.
Excellent. Thank you. Questions come through from Vinay, who's in the Middle East. So hello to Vinay. And this one might be for you, George. What is the design life of the concrete mattress? And just he's asked about the available design codes.
Yeah, well, in terms of design life, the concrete is good for over 100 years. The mattress itself we designed it to be just used as temporary works. In 99.9% of applications, just temporary. So then you're onto the design life of the concrete. So for that, we'd look towards your local standards. So in the UK, there's guidance for plain concrete in the marine environment to over 100 years. So that guidance is quite simple to comply with. We're happy for the mattress fabric to degrade and erode within 24 hours of placing the concrete. Really, it's done its purpose. And I think that's it. I think I've answered both parts. Design life and standards. Yeah, local standards for concrete.
Yeah. Well, maybe leading on from this one is a question came through. How are the mattresses maintained in the long run?
Maintained in the long run, as Charmaine hinted, there's very little maintenance to do to the concrete. We wouldn't. It would only be if there's been mechanical damage, maybe clumsy dredging, maybe impact with the ship, that sort of thing. Then you'd be looking at doing quite a specific repair to replace that sealed slab in that location. In terms of normal use, rocks running along the surface, flow, there'll be no need for maintenance on the mattress apron. It's all about the edges, making sure that mattress doesn't underscour, because that's how it's going to fail and kind of unzip. As one area gets underscoured, the concrete mattress can crack down into it, then the next bit further in gets underscoured and it progresses. So the maintenance, we really focus it on the edge and ensuring that there's no underscour there.
Excellent. Charmaine, I've got a question for you. It's come through from Assam. These mattresses come with specific length. How about joints between them?
So there are different ways to actually join them. So we can do in-situ sewing, or you could actually use zippers. So for birth protection projects, typically zippers are attached to each panel. So for instance, we have a panel of 15 meters by 50 meters long. So that's the first panel, and then you join the next panel with zippers that is attached on the ends of the panels. So if not for construction, for instance, for rivers, what we typically do, if it's a dry installation plan, we could also do in-situ sewing. So you actually sew the mattress along the way as you construct your lining protection over the river, for instance. So there are different ways to actually connect the panels together.
Excellent. And look, I think we are coming through to our final question for tonight. And this one's from Mia, and it is with regards to any objection from EPA regarding in-situ concrete in waterways. George may be the best person to answer that one.
Well, I can start from a UK perspective. That's where we get most of the contact with our environment agency here, or the Scottish Environmental Protection Agency, or Natural Resources Wales. So the three main people we're working with. So it's interesting, because usually we're in rivers, we're damming off one side of the water, or we're in such a large body of water. The effect of the bleed from the concrete is negligible. When we test for changes of PA in the water, it's almost undetectable, or it stays within the natural variation of the pH of the riverine environment. Most feedback we get is about not having a concrete mattress spanning from one side of the river to the other and being exposed, as this can affect the ecology. Now, this is something I'm not an expert on, but one thing that they've really worked with us to do is to make sure that we're protecting the piers, which is the parts of the bridge structures that need to be protected, and dipping the mattress down below the natural bed level, so that it's exposed minimally during flood conditions, so that very quickly the natural bed material can start to accumulate once again in the centre of the channel. So, like I say, I'm not an expert, but I understand that's the driving focus at the moment from the from the environment agencies in the UK.
Excellent. Thank you for that. Any final comments, Charmaine, before we wrap up?
No, similar as what George has mentioned on the EPA. So what we realize is that when we fill the concrete mattress on site, is that we don't really see much. The concrete milk that comes out is relatively it's what George says, negligible. So we have not, in our experience, we've not seen an issue with the EPA. In installation sites across in Europe, especially, it's all within the limits of the regulations.
Excellent. Well, look, that's all the time that we have for tonight. So please join me in once again thanking our speakers, Dr. Charmaine Chia and George Hawkeswood, for their time and input, and especially recognising George that he's up at the crack of dawn in the UK for our session tonight. I would also like to thank Engineers Australia's industry partner, Husker, for their support. Now, to help us improve and plan for our future Thought Leader sessions, could you please complete the short feedback form, which is linked in the description box below. Thank you again for joining us tonight, and we hope to see you at our next Thought Leaders event.